Hello, today we are covering lesson 4.3, congruent triangles. You will be able to name and use corresponding parts of congruent triangles and prove triangles are congruent using the definition of congruence. Our new vocab here is congruent, congruent polygons, and corresponding parts. So our first section here, congruence and corresponding parts. If two geometric figures have exactly the same shape and size, they're congruent. So in this first diagram, you'll notice 1, 2, and 3, they are rotated, but they are exactly the same shape and size, so they are considered congruent. In the second part, 4, 5, and 6 are not congruent. 4 and 5 are the same shape, but different sizes. 5 and 6 are the same size, but different shapes. So because they're not both the same shape and size, they are not congruent. So in two congruent polygons, all of the parts of one polygon are congruent to the corresponding or matching parts of the other polygon. These corresponding parts include corresponding angles and corresponding sides. So we are going to learn how to label these. So definition of congruent polygons. Two polygons are congruent if and only if their corresponding parts are congruent. So the corresponding parts just means that there are pairs of angles and sides that are congruent. And also it's an if and only if, so it works both ways. If their parts are congruent, then their polygons are congruent. If the polygons are congruent, then the parts are congruent. So we have that angles A and H are congruent. We have that B and J are congruent, and C and K are congruent. So we have three pairs of congruent corresponding parts for our angles. We also have corresponding sides congruent: AB, HJ, BC, JK, AC, and HK. These are congruent. You can just notice by the tick marks or by how it's written out that they're congruent. And then we have a congruent statement. Notice before we could just go ahead and write our triangle in any order we wanted to, but this time we have to be picky about the order. If we say ABC, we must go from the double tick line to the single tick line to the triple. So we have to go from double H to single J to triple K. And you have to write them in the same order because the order we write the congruent statement in is the order of the congruent corresponding parts. So we know based on this that A and H are congruent, angle B and angle J are congruent, angle C and angle K are congruent. Inside the green box, we read the phrase if and only if, and the congruent polygon definition means that both the conditional and its converse are true. So if two polygons are congruent, then their corresponding parts are congruent, and vice versa. We talked about that. For triangles, we say corresponding parts of congruent triangles are congruent or CPCTC. We are going to use this a whole bunch on upcoming proofs. I would highlight this, mark that in your brain. We are going to need this and use it a bunch. All right? So now we are going to identify corresponding congruent parts based on what we are given here, as well as write a congruence statement. So I know based on this, A and R are congruent. This is going to get pretty messy, so try to make yours as pretty as you can. B and T are congruent. Angle C and angle P are congruent. Angle D and angle S are congruent. And angle E and angle Q are congruent. So I didn't just look at the orientation of my shape. These can be rotated, which could throw us off a little bit. I looked at these guys over here to mark those out. I also need to mark out my segments. So AB and RT segments are congruent. Segment BC and TP are congruent. CD and PS are congruent. DE and SQ are congruent. And EA and QR are congruent. So yes, it is very messy. But we have identified our congruent corresponding parts, and now we can write our congruent statement. We know it will be polygon is congruent to another polygon. If I start at A, I need to go either A to E. I'm going to go either A to E or A to B. I'm going to go A, B, C, D, E, which means I went single, double, triple, quadruple, and then to the fifth one. And then I need to go that same way again, so R, T, P, S, Q. Notice this is not in alphabetical order. It's not always going to be in alphabetical order. I just followed my tick marks around to name the polygon. So we're going to do this again. I'm not going to talk through it too much. I will do the second one first because it is a little different. On this one, instead of having tick marks or hash marks, we have degrees. But that doesn't matter, just match the degrees to each other so you can follow along. So there is our angles. We also need to find our congruent segments or sides. All right, one thing I do want to point out, when you are writing these, make sure you leave your angle measures out front. You leave your segments on top. You need to have those for it to be proper notation. If you don't, I'll probably count you wrong because that's not actually proper notation. So make sure you are labeling correctly what you are doing. We also need to write a congruent statement for the triangles. This time you can just draw a little triangle. So if I go JKL, triangle JKL is congruent to triangle. I want 52, 78, 50. I'm going to do that again. PMQ, 52, 78, 50 as my congruent statement. I'll do the same thing with these trapezoid shapes. Name my congruent angles. It's nifty when they're in alphabetical order. That makes it pretty easy for us, like these ones are. All right, and then we need to write our congruent statement. So once again, it'll be polygon this time. And if I say CDAB, this will be, start with the triple, YZWX is our congruent statement here. All right, hopefully those weren't too bad there. Now we can use this idea to go ahead and solve for missing variables, missing side lengths, missing angles, right? We need to solve for the values of x and y, given that these triangles are congruent. Now I want to point out once again, when we have these set up like this, we know based on this that angle I and angle N are congruent. We know that angle T and angle G are congruent. We know that angle P and angle O are congruent. So you can either mark that up or just look at it and know. We also know that IT and NG are congruent. We know that TP and GO are congruent. We also know the two exteriors, IP and NO, are congruent for our segments. So we know a lot of things, we just have to pair them up correctly. So, if I am trying to find X and Y, and there's two variables here, I don't want to start with that, I want to start with solving for Y. I know that O, angle O, is congruent to angle P, so I'll just set them equal to each other and solve. So I solve. Y is going to equal 9. Then I know that I need this segment NG equal to something. Well, I know NG must equal IT, so I set them equal to each other. I already solved for Y, so I can just plug that in. And solve. So we have our two variables to solve for. Alrighty, when we end up putting two shapes together like this, it can get a little tricky. But actually it can also be helpful, because we then already know that F and H are congruent to each other. They're the same line, so this would be FH is congruent to FH by the reflexive property. We'll need this later, that's what I'm telling you now. We can also tell that just by this, that FH and HF are at the same spot in our congruence statement, so we know they're congruent to each other. Okay? Let's go ahead. We need to find the values of X and Y. It's kind of hard also when they're together like this to know what angle these guys are referring to, because angle F could really technically refer to 2 and angle H could refer to 2 as well. So I'm going to highlight my one triangle. I highlight the triangle that it corresponds to, FHJ, and then I go ahead and draw in my hash marks. So I started with 1 on F, 2 on H, 3 on J. Do the same thing on my unmarked triangle. So H has 1, F has 2, G has 3. Alright, now I know what I can set congruent to each other. So I know this 6x plus 8 really is congruent to 35. So I can solve. Oopsie, 6x. Go ahead and subtract. 6x equals 27. This will get us a decimal of 4.5, I do believe. Yes. So x is going to equal 4.5. Then we can find our segment lengths. If you look, the 2y minus 3 is between the single and the triple hash marks of the angles. And 2.5 is between the singles and the triples. So we set them equal because they are congruent. This problem is pretty easy because they didn't give us any extra information. But sometimes we have extra information and you really do have to decide what to make equal what. So we've now solved for our x's and our y's, and we are good to go. We have a new theorem here. This one's pretty self-explanatory. The third angles theorem. If two angles of one triangle are congruent to two angles of a second triangle, then the third angles of the triangle are congruent. So we know that C and K are congruent. We know that B and J are congruent. Let's just do a little example real quick. What if C and K are both 40 and B and J are both 60? Well, we know that A would have to be 80. And if we solve this one over here, L also has to be 80, which means they are also congruent. So the third angles theorem, if you have two pairs of congruent angles, you know the third pair has to be congruent in a triangle as well. So we're going to do two proofs using what we have learned. We have givens. We do have the given written into two sections. It doesn't really make much of a difference. It could be a 4-step proof if we were to put them into one, but they are written out for us. We do want to check to make sure everything is labeled. It looks like we have our angle labeled in our diagram, as well as our 3 sets of congruent sides. So we're good to go there. We don't have to label anything new, and we are trying to get to congruent triangles. So we need all 3 sets of sides to be congruent, and we need all 3 sets of angles to be congruent. If you think way back to the beginning of the year, we used vertical angles theorem a lot, and really we still use it quite a bit nowadays. So by the vertical angles theorem, or VAT, we can say that these two angles, angle L and M, are congruent. So L and M and P and O are congruent to each other. So now we have 3 sets of congruent sides and 2 sets of congruent angles. But lucky for us, we just got a new theorem called the third angles theorem that tells us that these 2 angles are also congruent. So angle M is congruent to angle O by that third angles theorem. And now that we have all 3 sets of both sides and angles, we can go ahead and say that our triangles are congruent. And this is by our beginning statement that I had you highlight. Corresponding parts of congruent triangles are congruent. Which can just be shortened to CPCTC. Just make sure you know what you're talking about and remember both the written version and also the abbreviation if you're using it. And that's it for that proof. All right, so our next proof, we are once again given our givens. Not everything is labeled though on our picture, just the segments are. So I'm going to label our angles. So there's one of them, and our second set of angles, NPQ and PNO are congruent as well. So now, if you recall, I talked about it earlier. If there is a shared segment, that means it is congruent to itself. So we can use the reflexive property to go ahead and say that those are congruent to each other. This one actually makes sense as opposed to some of our other reflexive properties when we use it, because we have to state that that segment has a congruent buddy. Then the last thing we have to do is simply state that this third angle in each triangle is congruent. Thankfully for us, we once again have that third angles theorem. So we can state that angle QNP is congruent to angle OPN. And then we've got all 3 sides congruent, pairs of sides congruent, and all 3 pairs of angles congruent, so we can say that our triangles are congruent. QNP is congruent to triangle OPN. And that is once again by corresponding parts of congruent triangles congruent. All right, and last slide here, we have properties of triangle congruence. I told you at the beginning of the year, we're going to have reflexive, symmetric, and transitive properties, a whole bunch. It also works with triangles. A triangle is congruent to itself. Two triangles are congruent to each other no matter which way you write it. And then the transitive property, if two triangles are congruent and the second one is congruent to another one, then the first and the last are also congruent. All right, that'll do for today. Have a great afternoon.